All right, we are going to do section 3.4. This is a fun section. We're going to solve systems with three variables. The steps can get pretty long in systems with three variables, but once you get to the final answer and you find out that it's right, it's a pretty awesome feeling. This is the steps we would follow in order to solve a system of three equations. We're going to use the elimination method. To start out with, in the elimination method, what you need to do is first get rid of the same variable twice, okay? So what I'm going to do is I'm going to start with the first two equations. And if you look at the z's, if I add those together right now, I could pretty easily get rid of the z's. So that's what I'm going to do to start with. I'm just going to rewrite the first two equations. Just like we started out systems of two equations, okay? And the reason why I picked the first two to start with is you notice we've got minus z plus z. So when I add these together, the z's are going to cancel each other out, and that's a pretty sweet deal. So we've got x plus 2x is 3x, and then 3y plus y is plus 4y. Z's are gone, equals negative 10, okay? So now you see I have an equation with just x and y. Now what we need to do is we need to find another equation with just x and y so that we can work with just the x and the y. So I need to get rid of the z again. Okay, you always get rid of the same variable the second time as well. Now I have to use this third equation. I absolutely have to, because I'm not going to go back and use the first two again, because that would just get me right back to where I was. So I have to use the third equation, and notice it's 3z. So that means I'm going to need a negative 3z in order to eliminate the z again. So I'm going to take this first equation, since it's minus z right now, I'm going to take the first equation and multiply it by 3, okay? Then I know when I'm going to rewrite the third equation. I've got 5x minus 2y plus 3z equals 21. Okay? Now I take the first one, multiply everything by 3, that's going to give me 3x plus 9y minus 3z equals negative 33. Always remember to multiply the right side of the equal sign by that number as well. So now when I add these up, I've got 8x plus 7y. The z's cancel out, equals negative 12. All right? So now I have two equations with just x and y. With these two equations, it works just like when we had two equations before. I need to decide, do I want to get rid of x or do I want to get rid of y? For these two, it probably doesn't matter real much which one you're going to get rid of. I'm going to go ahead and get rid of the x, okay? So I'm going to take the first one and I'm going to multiply it by 8, okay? And so that'll give me a 24x. So let's start by doing that. 24x plus 32y equals negative 80. Then I need to multiply the second one by negative 3, okay, because we need those x's to also be opposites. So I needed a negative 24x minus 21y equals positive 36. Okay, now I add these together. So I've got 11y, bye Eli, he's got football, equals negative 80 plus 36 is negative 44. Divide by 11. So then y ends up being negative 4. So I have my value for y. Now what I'm going to do is I'm going to take this back to one of these two equations that I boxed in purple, okay? Because they have just x and y. If I went and plugged the y into one of these, I'm going to have an x and a z, so I can't really solve for another variable. So what I need to do is pick one of these two, doesn't matter which one, Let's do the 8x plus 7y equals negative 12. So I'm going to take this y and plug it into here. So I would have 8x plus 7 times negative 4 equals negative 12. Continue to work that out. I've got 8x, that'd be minus 28 equals negative 12. Now I'm going to add 28 to both sides. So I have 8x equals 16. Now we just divide both sides by 8, and x is 2. Now I have 2 variables solved for. So what I'm going to do for my last step is I'm going to go back to one of these 3 originals. It doesn't matter which one. You can use any of those 3 that you want to. I actually would say the second one. I like that one. I'm going to pick the second one, and I'm going to plug x and y back into that. My x is 2, so it's going to be 2 times 2 plus y is negative 4 plus z equals 1. So I'd have 4, that's going to be minus 4, plus z equals 1. And you'll see here 4 minus 4 is 0, so that cancels out, which means z is 1. All right, now this was a lot of steps, got a lot of stuff going on here, but I ended up finding my answer of 2, negative 4, 1. Notice I wrote my answer as a point, just like I did with 2 equations. We do have points that have 3 variables, and that would be a 3D graph, okay? So, and remember, it always goes alphabetical order, x, y, z. Now, just like with 2 equations, you can always check, and you should always check to make sure that you've got the correct answer. And all you need to do is take this, plug it back into all 3 of the original equations. It's got to work in all 3. If I did that real quick, 2 plus negative 12 minus 1. 2 plus negative 12 is negative 10. Minus the 1 would be negative 11. Works for the first one. 2 times 2 is 4, plus negative 4, that'd be 0. 1 equals 1. Works for the second one. 5 times 2 is 10, plus 8. 10 plus 8 is 2. Just kidding. 10 plus 8 is 18, plus 3 times 1 is 3. 18 plus 3 is 21. And please make sure you always check it into all 3. There have been times where I've checked and it's worked for the first 2 and not for the last one. So do please check and make sure it works for all 3 equations. One more. I want to get rid of, it doesn't matter which variable I choose, okay? I can choose any of them. Now you see, we got 2z and 2z. I could just make one of those negative and get rid of the z's again. Just to mix things up though, let's work with the x's, okay? Since this one's already 12, I'm going to take the first one and multiply it by negative 2. So when I rewrite that, I'd have negative 12x plus 12y, watch your signs there, minus 4z equals positive 10. And then I'm going to rewrite the second equation, 12x plus 3y plus 4z equals 0. I'm going to add these up. These x's cancel out. I have 15y. The z's also cancel out. That's interesting. Equals 10. Divide everything by 15. So I end up with y equals 2/3. Okay, 10/15 is also known as 2/3. So I already have my y variable solved for. Now, if you remember back in the beginning, what I did was I got rid of the x's. So I'm going to still continue to get rid of the x's. I'm going to rewrite the second equation again, because I'm going to use the second and the third equations together. So I have 12x plus 3y plus 4z equals 0. Okay? Now what I need to do to get rid of the x's, I'm going to take this third one and multiply by negative 3. When I do that, I end up with negative 12x minus 27y minus 6z equals negative 18. When I add those up, x's are gone. I'd have negative 24y minus 2z equals negative 18. Okay? Now this time, the equation did end up with a y and a z. But the cool thing is I already know what y is. So I'm going to take that and I'm going to plug it in for that y right there. So I'm going to end up with negative 24 times 2/3 minus the 2z equals negative 18. Let's do this math here. Remember, 3 goes into 24 8 times. Negative 8 times 2 is going to be negative 16 minus 2z equals negative 18. Now we add 16 to both sides. That gives me negative 2z equals negative 2. Divide by negative 2. Z is 1. Now I have a y and a z. All I need to do is go back to one of my originals and plug it in. And I'm going to plug it into, I'm going to do the first equation. So I end up with, let's see, we don't know what x is yet, so it'll be 6x minus 6 times 2/3 plus 2 times 1 equals negative 5. Continue, 6x minus 4, because 3 goes into 6 twice, so it'd be 2 times 2, plus 2 equals negative 5. 6x, combine these like terms, it'd be minus 2 equals negative 5. Add 2, so 6x is negative 3. Divide by 6, and x is negative 1/2. Okay? So we end up with an answer of negative 1/2, 2/3, 1. Never be afraid of fractions. They are okay answers. This point does actually work for all 3 equations. And that completes our system of 3 equations.